So welcome everyone for this second lecture on buses, its architecture and types. So this is going to be the contents. We'll start with the basics of bus, then bus architecture, typical bus transactions, types of buses, and classification of buses on the basis of personal computer. So first of all, what is bus? So bus is a set of wires or set of lines that act as a shared but common data path to connect multiple units within the system. So the lines which are there in the buses, so they basically allows the parallel movement of bits that is required for the data or maybe address or control signals. So speed of the bus is affected by its length as well as by the number of devices that are actually sharing that bus, right? Size of the bus, or you can call it the number of bits in a particular bus or number of lines is known as its width that determines how much data can be transmitted at one time. Or if it is an address bus, then it will determine how many different memory locations we can address. So if I take a simple example, let's say there is an address bus and its width is, let's suppose, 8 bits. So through those 8 bits, we can address or we can generate address for 2 raised to the power 8 memory locations, right? Every bus has a clock speed which is measured in either megahertz or gigahertz. So a faster bus, obviously, it will allow data to be transferred faster, which will affect the overall performance of our system and our applications would run faster. Now the question is, what are the requirements of having a bus? So it is required for communication among the different units within the system. The CPU communicates with the other component via a bus. So generally we call it a system bus, which connects the major components within the system. So buses makes it easy to connect new devices to each other and to the system. So how actually it works? So it transfer electrical signals from one place to another place. Basically it is those signals are we generally represent in the form of bits. So as we know, a bit can be either a 0 or a 1. So an actual bus appears as an endless amount of edged copper circuits on the motherboard surface. And there is a specific component that is known as bus interface unit, which is actually required to connect the bus with the CPU. The data travels between the CPU and the memory along the data bus. All right, so we'll discuss the different type of buses in the further slides, right? And for the synchronization purpose, we have a clock, right? Where which actually keeps track of the uh, synchronization part when the data is transferred. Now, what are the advantages of having bus? So obviously these are low cost and very versatile. And when we talk about the disadvantages, so there may be multiple limitations. Let's call it limitations. So at any one time, only one device uh, only one device can use the bus. So if it is a shared bus, then only one device can communicate at a particular time, or you can say within a particular clock cycle, right? So there are certain methods to overcome these disadvantages. So examples of typical buses, industry standard buses are like ISA bus, which is industry standard architecture, EISA, SCSI, PCI. So these are the different buses that we generally use in our system. So this is the architecture. So what we have here is we have CPU, memory, and input-output devices here. And we have three different types of buses that you can see here. So one is control bus. Obviously, this control bus would be required to send the control signals from the control unit to the other units in the system. Then address bus. So once we'll be accessing the memory, so we'll be requiring to send the address. So for that, we'll be using the address bus. And one more thing, the width of the address bus actually determines how many locations we can access, right? Then data bus, so how much data parallelly we can transfer. So again, that will depend on the width of the data bus. And if I talk about the whether they are, so a bus can be a unidirectional or bidirectional, right? So when we talk about data bus, so it is bidirectional. So CPU can send the data and perform the write operation on the memory as well as it can read the data. Address bus is actually unidirectional because only CPU would send the address to the memory, whatever the location it wants to access, right? And these control bus are also unidirectional because generally the control unit would send the control signals to all other units, right? So control bus would control the overall functionality of the system. Address bus for accessing any address in the memory, and data bus for the transfer of the data to and from the memory, right? So these are the different components. So we have control lines that actually signifying the control bus, address lines, and data lines. So whatever the devices we are having in the system, so obviously they need to follow some set of rules to use the bus, right? So we'll in the further lecture we'll discuss the different bus arbitration techniques, how a particular bus can be used by the multiple units. Okay. So first of all, data bus. So data bus is dedicated to moving data to and from the memory, right? Or maybe we can access the data from the registers also. Okay. Address lines are to indicate the address or location in the memory, whatever the location we want to we want the data to be read from, or maybe we want to write the data onto a certain location. So we in that case we need to be we need to give the address to the memory through the address, right? Similarly, we have control lines. So control lines are basically to send the control signals to the from the control unit to the all other units of the system. The other operation that can be performed by the control line, other than indicating a particular operation, uh, it may be used for bus request, bus interrupt, then clock synchronization signal, reading from the memory, writing onto the memory, or performing some operation in the ALU. So this is what I was mentioning earlier. So address bus, it is unidirectional. Data bus, that is again it is bidirectional, so we can read the data from the memory or we can write the data onto the memory. And control bus, it carries the control and timing signals for overall coordination of the different operations within the system, right? Now what are the typical bus transactions? So in previous slide also we have given some examples, right? uh, Other operations may be we may send the address to the memory for performing any read or write operation. We may transfer the data from memory to a register or vice versa. Like we may write the data onto the memory from the register also. So it is memory read and memory write. And there are certain buses that are used for IO transfer also. Right? So buses uh, again this all thing would be governed by the clock. So clock synchronization needs to be done. Then there are different type of buses. So one is point to point buses. So those buses that connect to specific component, these are point-to-point buses. Multi-port buses are also there, in which the bus would be shared by the number of devices. Then processor memory bus, so we may use dedicated processor memory bus also, which will transfer the data between the processor and the. Okay. And input output buses are also there that would be responsible for transferring the data between the uh, processor and the input output devices, or maybe directly from input output devices and memory, right? So there is one more classification. Uh, Generally what we do, like, for data, we have, for data and address we have separate buses, right? So for data we have data bus, and for address we have address bus. So this architecture is known as dedicated bus architecture. All right. So other architecture is multiplexed bus architecture. So what happens in this multiplexed bus architecture is we are using the same bus for the data as well as the address. So what we'll be doing, we'll be having a specific uh, signal, that is address valid signal. So once we need to send the data, or maybe once we need to read some data from the memory. So first of all, we need to specify the address. So what we'll be doing, when we are sending the address to the memory, so there is a this address valid signal. So we'll just turn on this address valid signal. Okay. We'll just make it one when we'll be sending the address. Now once we have sent this address to the memory, so what we need to do now, we need to use the same bus for reading the data. So in that case, we will just turn off this address valid signal. So once this address valid signal is turned off, so same bus would be used for transferring the data. Okay. So using this address valid signal, so if it is 1, then it is indicating this that we are transferring the address for memory read or memory write operation. And once this is off, this is 0. So the same bus would be used for the data, for transferring the data. So this is how we are using the multiplexing inside the bus, right? Now, what are the advantages of having a dedicated bus? So if we are having a dedicated bus, so obviously the waiting time would be less, and overall throughput of the system would increase. But it will increase the overall cost, or you can say it will increase the overall number of lines, because we are having the separate bus for the data and the address. Okay. Using multiplexed bus architecture, so we'll be having fewer lines. So fewer lines, so we would have rather a bit complex architecture, but number of lines would be fewer, so less cost and space would be required for the overall setup of the bus. But what would be the disadvantage, or we generally call it limitation? So overall performance of the system would be increased, and we need more complex circuit for maintaining this overall architecture. So this is what bus is all about. So what we have seen, if I give you a quick recap. So one is, we have discussed what is bus, then what are the different type of bus. So data bus, address bus, and the control bus. Then at the last, we have seen what are the different types of buses. So we may have dedicated architecture, or we may have multiplexed bus architecture. Right. So in the next lecture, we'll discuss about the different bus arbitration technique, and uh, why exactly we need this bus arbitration, and what are the different techniques to manage the overall buses that are there in the system. So that's all for this lecture. Thank you.